So in this video, I am going to explain worksheet questions of stoichiometry, so which is very important topic. So in this video also I have selected important models for competitive exams. We will discuss one by one. So first question, which of the following are disproportionation reactions? So here disproportionation means single oxidation state will be converted to two different oxidation states. So here single oxidation state can be intermediate oxidation state. So single intermediate oxidation state will be converted to two different oxidation states. So if you check options A, in option A, Cl2 is converted to Cl minus plus OCl minus. So Cl2 oxidation state 0. Next here minus 1 clearly. Next for Cl here plus 1. So 0 to minus 1, 0 to minus 1 reduction, 0 to plus 1 oxidation. That means single oxidation state is divided into two different. Therefore, it is disproportionation. Next, check B option. H2O2 changes to H2O plus O2. I am not balancing here. Next here oxygen, oxidation state minus 1 changes to here minus 2 and here 0. Minus 1 to minus 2 reduction, minus 1 to 0 oxidation. Therefore, disproportionation. Next C. KMnO4. So KMnO4 means potassium permanganate plus 7 oxidation state, that changes to K2MnO4, which is plus 6 plus MnO2, which is plus 4. So here both are reductions. Therefore, this is not disproportionation. So disproportionation means the same substance undergoes oxidation and reduction simultaneously. Here both are reductions. Next, D option. MnO4 2 minus, which is plus 6, changes to MnO4 minus 1, that is plus 7 plus MnO2, so which is plus 4. So plus 6 to plus 7 oxidation, plus 6 to plus 4 reduction. Both are happening here. So therefore A, B, D are disproportionation. Therefore option B. Next question. Very important. Magnetite can be reduced with CO. We know magnetite means Fe3O4. Reducing agent is CO. That will be converted to Fe plus CO2. So by balancing we'll get 4 moles of CO, 4 moles of CO2 and 3 moles of Fe. Next here 1 mole of magnetite gives 3 moles of Fe. So 1 mole means gram molecular weight 232 grams will give 3 into 56 grams. 56 is atomic weight of iron. Therefore 4 kg of iron will be obtained from 4 kg. Say this is X. Therefore X equal to 4 into 232 by 3 into 56. We'll get value as 5.52 kg if it is 100%. Therefore, calculate the mass of magnetite. Magnetite, which is 80%, will be equal to 5.52 into 100 by 80. If percentage of purity is less, more quantity is required. Therefore, more percentage by less percentage. we'll get this value as 6.9 kg. Therefore, option D. If it is 100% of magnetite, only 5.5 kg is required. 5.52 kg is required. If it is 80% purity, more quantity is required. Therefore, 6.9 is required. Next. So, very important model. Number of moles of ferrous oxalate oxidized by 1 mole of KMnO4 in acidic medium. So, KMnO4, I am taking here MnO4 minus changes to Mn2 plus. So, here oxidation state is plus 7 and here plus 2. So, therefore, 5 electrons will be added here. 5 electrons. This is expression 1. Next, ferrous oxalate FeC2O4 changes to here Fe2 plus C2O4 2 minus Fe2 plus changes to Fe3 plus and oxalate will be changed to CO2. Take a 2 moles of CO2. So for Fe2 plus to Fe3 plus Fe2 plus to Fe3 plus n factor equal to 1. That means 1 electron is required. C2O4 2 minus to CO2 n factor 2. So total n factor 1 plus 2 3. So therefore 3 electrons will be added here. Expression 2. So in expression 1 we will be having 5 electrons. Expression 2 3 electrons. Therefore multiply expression 1 with 3 and 2 with 5. Therefore 3 moles of KMnO4 will be equal to 5 moles of FeC2O4 ferrous oxalate. Therefore, so 1 mole of KMnO4 will be equal to 5 by 3 moles of FeC2O4. 5 by 3 is the answer. Option D. So here 5 electrons is n factor. In acidic medium, KMnO4 minus will be changed to Mn2 plus, n factor is 5. For ferrous oxalate, total n factor is 3. Expression 1 with 3, expression 2 with 5 multiplication. To balance electrons. So 1 mole of KMnO4 oxidizes 5 by 3 mole of FeC2O4 ferrous oxalate. Next. So identify the values of A, B, C, D, E from the following unbalanced equation. So here given equation must be here KNO3 plus should be there. KNO3 plus. So here unbalanced equation is KNO3 plus C12 H22O11 which is sucrose gives N2 plus CO2 plus H2O plus K2CO3. This unbalanced equation or skeletal equation. Here we should find the values. Take here A value, here B value, C, D and E. So clearly by substituting these numbers or stoichiometric coefficients will get A value as 48, B value 24, next C value 36, D value 55 and E value as 24. By balancing atoms on both sides, we'll get these numbers. So here A, B, C, D, E are stoichiometric coefficients. And here we'll get value 5 moles. So clearly option D. Just a simple balancing. KNO3 reacts with sucrose. This is sucrose or cane sugar. That will be changed to N2 dinitrogen, CO2 carbon dioxide, water and potassium carbonate. Just balancing of equation only. Balancing of atoms on both sides. Next one. So amount of 50% HCl required to react with 200 grams of CaCO3 would be. This is also simple question. Here CaCO3 reacts with 2 moles of HCl to form CaCl2 plus H2O plus CO2. So here 1 mole reacts with 2 moles. 1 mole means gram molecular weight. 100 grams reacts with 2 into 36.5 grams. That is simply 73 grams. For 100 grams, that 73 grams of HCl is required. Therefore, for 200 grams, so double the value means 146 grams of HCl is required. Therefore, 50% HCl required is, so for 200 grams of CaCO3, 146 grams of HCl is required if it is 100% pure. If it is 50% pure, we'll get 146 into more percentage by less percentage. That is 146 into 2. Therefore, 292 grams. Option B. So, to react with 200 grams of CaCO3, if it is 100% pure, 146 grams of HCl is required. If it is 50% pure, double amount required. Therefore, 146 into more percentage by less percentage. Option B. Next. This one also simple. From the following reactions, identify disproportionation. So, in a disproportionation, single oxidation state will be divided into two different oxidation states. A single oxidation state can be intermediate oxidation state. Clearly options verification. See, first option, Cl2 plus 2I minus gives 2Cl minus plus I2. This is redox reaction but not disproportionation. So a disproportionation means the same substance undergoes both oxidation and reduction simultaneously. Here Cl2 is reduced and I minus is oxidized. Redox but not disproportionation. Take second option. Cl2 changes to Cl minus plus OCl minus. Here Cl state is 0. Here minus 1 for Cl. Here for Cl plus 1. So 0 to minus 1 reduction, 0 to plus 1 oxidation. That means same substance is reduced as well as oxidized. Therefore, it is disproportionation. Third, magnesium plus 2H plus gives Mg2 plus H2. So here magnesium is oxidized and H plus is reduced. Redox but not disproportionation. Fourth option, I am taking just H2O2 gives H2O plus O2. So here O oxidation state -1, here O state -2, here O state 0. So single oxidation state is divided into two different. Therefore disproportionation. Therefore 2 and 4. 2 and 4 B option. So all are redox reactions only, but disproportionation means same substance should undergo oxidation and reduction simultaneously. Here in second, fourth options, single compound is oxidized as well as reduced. Next question. So very important. Here 100 grams of mixture of NaOH and Na2SO4 given. NaOH plus Na2SO4 total 100 grams mixture. Here take x grams, then it becomes 100 minus x grams. Next. So here NaOH will be neutralized by H2SO4 because NaOH is base, H2SO4 is acid. Acid base neutralization. Therefore, you can write milliequivalents of NaOH equal to milliequivalents of H2SO4. So milliequivalents of NaOH means we can write W by E into 1000, weight by equivalent weight into 1000. Here milliequivalents means normality into volume. Here normality is not given, therefore molarity into N factor into volume. So weight of NaOH X by equivalent weight 40. So in case of NaOH, equivalent weight equal to molecular weight into 1000 equal to molarity is given 0.5 into 100 into N factor of H2SO4 2. So therefore we'll get X value as 200 into 5, 100, and therefore X value 4 grams. Here X value is NaOH. Next 100 minus X grams, that is 96 grams Na2SO4. So here what is asked, what is the amount of Na2SO4 here? Wrong is given. It should be Na2SO4. Na2SO4 weight 96 grams. Therefore option B. Very important. NaOH 4 grams, Na2SO4 96 grams. So here H2SO4 neutralizes only NaOH. Because NaOH is base, Na2SO4 is salt. Next. So number of grams of oxygen present in 32.2 grams of Na2SO4 10H2O is approximately. So here given Na2SO4 dot 10H2O, which is hydrated salt. So molecular weight of this compound is 322. So here 1 mole of salt, 1 mole of salt contains, so how many oxygens? 10 plus 4, 14 moles of oxygen atoms. This is standard condition. 1 mole of given salt contains. So name of this compound is Glauber salt. Remember this, Glauber salt. Given salt contains, if you take 1 mole of salt, 14 moles of oxygen atoms. So 1 mole means here 322 grams. 322 grams contains 4 moles of oxygen atoms. Therefore, given weight is 32.2 grams contains. So here by 10, it should be by 10. That means 1.4 moles of oxygen atoms. So therefore, 1.4 moles of oxygen atoms means 1.4 into gram atomic weight of oxygen. So which is 1.4 into 16, which is equal to 22.4 grams. Therefore, option B. Simple calculation. Next one. For a given unbalanced equation, which is limiting reagent, if the initial amount of each reactant is 100 grams, we have to find limiting reagent. So first I will write unbalanced equation. MnO2 plus HCl gives MnCl2 plus H2O plus here Cl2 should be there. So in equation, so Cl2 is missed, I am writing here. H2O plus Cl2 must be there. Next, by balancing, we'll get stoichiometric coefficients. 4HCl, 2H2O plus Cl2. So this is manufactured of Cl2. Next here 1 mole and here 4 moles. So 1 mole means here 87 grams MnO2 and here 146 grams. Therefore, I am taking here 1 gram. For 1 gram of MnO2, 1.67 grams of HCl is required according to equation. But given 100 grams of MnO2 and 100 grams of HCl are given. So basing on this, we can decide which is limiting reagent. So here for 1 gram of MnO2, 1.67 grams of HCl is required. For 100 grams, 167 is required. But 167 is not present. Therefore, HCl becomes limiting. And MnO2 becomes excess reagent. Simple. Option B. So for 1 gram of MnO2, 1.61 grams of HCl is required. For 100 grams of MnO2, 167 grams is required. 167 is not present for HCl. Therefore, HCl is limiting. Limiting reagent means which is totally consumed in a chemical reaction. Totally reacted. Excess means which is left after completion of reaction. Next. This is also simple question. What is the percentage strength of H2O2? Here simple formula. Percentage strength equal to 17 by 56 into volume strength. Simple formula in case of H2O2. That is equal to 17 by 56 into volume strength. 22.4 volumes given. So by solving, we'll get 6.8%. So which is weight by volume percentage of H2O2. Here percentage strength means weight by volume percentage of H2O2. Simple formula. Option D. So very important. Relation between percentage strength and volume strength. 17 by 56 into volume strength. Next. So how many moles of ammonia are produced by 5 moles of hydrogen? This is also a simple question. So we know N2 plus 3H2 gives 2NH3. So here 1 mole of N2, 3 moles of H2 and 2 moles of NH3. The relation between ammonia and hydrogen. So here 3 moles of hydrogen equal to 2 moles of NH3 according to equation. But here we have to produce how many moles of NH3 by using 5 moles of hydrogen. Therefore, I am using here 5 moles. 5 moles of H2 will be equal to say X moles. So therefore, X value will be cross multiplication. So 2 into 5 by 3. So which is 3.3 moles of NH3. 3.3 is the answer. Option D. Next. So this is also simple. A spherical ball of radius is given or 7 centimeters. So from radius we can find volume. Volume equal to 4 by 3 pi r cube. So which is 4 by 3 into pi value 3.14 into 7 cube. Next, density is given, density 1.4 grams per centimeter cube. So from this we can find weight. Weight equal to volume into density. So volume 4 by 3 into 3.14 into 7 cube into density 1.4. We'll get this value as 2010.43 grams. Next. See here, spherical ball of radius 7 centimeters contains 56% of iron. That means if we take 100 grams of ball contains 56 grams of iron. This is given condition. Given. So therefore, weight of ball is 2010.43 grams of ball contains how much amount of iron? Say x grams of iron. So therefore, x value will be on cross multiplication, we will get x value as 1125.8 grams. Therefore, moles of iron equal to weight by atomic weight. Weight 1125.8 by 56. Let this value as 20.1 moles. Option B. So first calculation of volume, after that weight, total weight of ball 2010.43. 100 grams of ball contains 56 grams of iron, that is given. So from this 2010.43 grams of ball contains 1125.8 grams of iron. So from this we are getting moles. Moles of iron means weight by atomic weight. 20.1 moles of iron. Next. Take here, in 1 liter vessel, 10 moles of methane, 50 moles of O2 are present. Number of moles of O2, water, CO2 present in vessel after vessel was heated to burn methane completely. That means here simply combustion of methane. So methane on combustion, that means reaction with O2 gives CO2 plus H2O, balancing here 2H2O and 2O2. So clearly here 1 mole, or I will take all are gases. So water is also present in the form of vapor. So here 1 volume, 2 volumes, 1 volume and 2 volumes according to Gay-Lussac's law. Next here 10 volumes of methane is given, 10 volumes. Or here we can take 1 mole, 2 moles, 1 mole and 2 moles. So here 10 moles of methane requires 20 moles of oxygen, and here 10 moles of CO2 will be formed and 20 moles of H2O will be formed. So totally 50 moles of oxygen we are taking, 50 moles. So therefore moles of O2 left. We are taking 50 moles, 20 are reacting. Therefore 30 moles left. So 30 moles of O2. Next water 20 and CO2 10. Therefore option B. 10 moles of CO2 and 20 moles of H2 are formed. So out of 50 moles of O2, 20 moles reacting here, 50 minus 20, 30 moles of O2 left. Therefore, a vessel contains 30 moles of O2 and 10 moles of CO2, 20 moles of H2. Next. So this one also simple one. So first CaCO3 decomposition. I am taking here CaCO3 on heating gives CaO plus CO2. This CO2 liberated from decomposition of CaCO3 will be neutralized by 28 grams of KOH, that is given. Here, if we take 100 grams of CaCO3, 44 grams of CO2 will be obtained according to equation. But here 60 grams is given, therefore for 60 grams, say here x grams. So therefore x grams equal to cross multiplication 44 into 60 by 100, which is equal to 26.4 grams of CO2 will be obtained. This will be neutralized by 28 grams of KOH. But actually, reaction between KOH and CO2 is given by KOH plus CO2, K2CO3 plus H2O. So here 2 into 56 grams will be neutralized by 44 grams. That means for neutralizing 44 grams of CO2, 2 into 56 grams of KOH is required. But here 28 is given. 28 grams of KOH. Therefore, take here Y grams. Therefore, from this Y value will be equal to 44 into 28 by 2 into 56, which is 11 grams. So, actually 28 grams of KOH neutralizes only 11 grams of CO2. 11 grams of CO2. But here in question, KOH neutralizes 26.4 grams of CO2. Therefore, percentage of purity will be given by pure amount by impure amount into 100. Therefore, pure amount. 28 grams of KOH neutralizes only 11 grams of CO2. That is pure quantity. By impure quantity, it is neutralizing 26.4 grams. That is into 100. Therefore, percentage of purity will be 41.6%. Option A. Observe the problem clearly. Actually, 28 grams of KOH neutralizes only 11 grams of CO2 if it is 100%. But in question it is given 28 grams of KOH neutralizes 26.4 grams of CO2. So, percentage of purity is pure amount by impure amount into 100. Next. After rounding off 1.235, 1.225 will have their answers respectively as. So, here 1.235 is given. So, here 5 is there. Therefore, add 1 to previous number. Therefore, it gives 1.24. Next, again 1.22. 225 is given. Next, 1.225 means here is it is 5. Therefore, add 1 to previous number. 1.23. Therefore, after rounding off, we will get 1.24, 1.23. Therefore, option will be D, not D. Option will be B. Wrong is given. Option is B. 1.24, 1.23 here. So, option B. So, at last 5 is there. Therefore, add one number to, that means one digit to before number. 1.24. Next, 1.23. Next question. In Haber's process, 50 grams of N2 and 10 grams of H2 are mixed to produce NH3. What is the number of moles of NH3 formed? Here first we should find limiting reagent. N2 plus 3H2 gives 2 NH3. So here N2 means 1 mole. 1 mole means 28 grams. 3H2 6 grams gives total 34 grams according to equation. So therefore, for 1 gram of H2, how much amount of N2 is required? 4.66 grams of N2 is required. For 1 gram of H2, 4.66 grams of N2 is required. But here we are taking given weights. Here I am taking 50 grams and here 10 grams. Next, therefore, here for 1 gram, 5 grams is required. Simple. So, for 1 gram of H2, 4.66 grams of N2 is required. For 1 gram of H2, 5 grams of N2 is present. Therefore, excess quantity of N2 is present. Therefore, N2 is excess and H2 is limiting. So, from H2 we can calculate ammonia formation. That means 3 moles of H2 is equal to 2 moles of NH3. That is 3 moles means 6 grams will be equal to 2 into 17, which is 34 grams. So therefore here we are taking H2 10 grams. 10 grams will give, say this is X grams. Therefore X equal to cross multiplication 340 by 6. So which is equal to 56.6 grams. Next, therefore moles equal to moles of NH3 is equal to 56.6 by 17 molecular weight. Weight by molecular weight. Therefore, it will be 330 3.33. The wrong is given 3.33. 3.33. Answer should be 3.33. 3.33 moles of NH3. So very important question. So first process is finding limiting reagent. Next, based on limiting reagent, we can calculate the amount of product. Next one. This is a simple question only. Observe the following reaction. I2 plus HNO3 gives HAO3 plus NO2 plus H2O. What is the equivalent weight of HNO3? So here HNO3 is oxidizing agent or oxidant. So equivalent weight equal to molecular weight by change in oxidation state. Simple question. So here on reactant side HNO3 is present, on product side NO2 is present. Here N oxidation state plus 5 and here N oxidation state plus 4. So change in oxidation state which is equal to molecular weight by N factor. Therefore N factor becomes change in oxidation state 5 minus 4 equal to 1. So therefore equivalent weight equal to say molecular weight of HNO3 is M by N factor which is M by 1, that is simply M. So in this reaction equivalent weight of HNO3 is same as that of molecular weight. Therefore option A. Next. If 50% of 1 molar Na2SO4 is dissolved in aqueous solution of density 1.2 grams per ml, what is the molality of Na plus in the solution? Here first Na2SO4 is given. Na2SO4 dissociates to 2Na plus SO4 2 minus. Here 1 molar given. Here we will get 2 molar. And here again 1 molar. Or we can say 1 mole, 2 moles and 1 mole. So here molecular weight of Na2SO4 is 142 for Na2SO4. Remember this molecular. Next, here we are taking 50% of 1 molar Na2SO4. That means 50% means we can take 1 molar. So actually from 1 molar Na2SO4 we are getting 2 molar Na plus, but here we are taking 50%, that means 1 molar. Next, 1 molar Na plus will be equal to 1000 ml. You know this. 1 molar Na plus means 1 mole of Na plus present in 1000 ml of solution. So from this, weight of solution equal to volume into density. Density is given as 1.2. So we'll get this as 1200 grams. Next, weight of solvent equal to weight of solution which is 1200 minus weight of solute. So weight of solute means molecular weight only, 1 molar. 1 molar means 1 molecular weight present. Therefore 142. So which is equal to 1058 grams. So from this molality, small m equal to number of moles into 1000 by weight of solvent in grams. Therefore small m equal to Na plus 1 molar. Therefore 1 into 1000 by 1058. Therefore molality will be equal to 0.95 molar. So option A. So actually 2 molar Na plus is present, but we are taking 50%. That means 1 molar. 1 molar means 1 mole of Na plus present in 1000 ml. So from this weight of solution and weight of solvent. Weight of solvent means weight of solution minus weight of solute. Next. So which of the following is not a disproportionation reaction? Here take CaCO3 changes to CaO plus CO2. The Ca state 2 plus, carbon state 4 plus, oxygen state 2 minus. Next here again Ca 2 plus, O 2 minus, carbon 4 plus and oxygen 2 minus. So therefore there is no change in oxidation state. No change in oxidation state of any element. Therefore not redox, not disproportionation. Therefore option A. In remaining cases, so one element will be oxidized or reduced simultaneously. One element or one substance. If you take second option, this is A. In B option, P4 changes to H2PO2 minus plus PH3. So 0 state, here plus 1 state and here minus 3 state. Disproportionation. C option. So already we have discussed H2O2 gives H2O plus O2. Here minus 1, here minus 2 and 0. Next option D. Cu plus changes to Cu2 plus and Cu0. So single oxidation state changes to two different. Therefore B, C, D are disproportionation. Next. So how many grams of magnesium is required to completely reduce 100 ml of 0.1 molar NO3 minus solution by using the following relation? So here we can write milli equivalents of magnesium equal to milli equivalents of nitrate ions according to law of equivalence. So here we can write W by E into 1000 equal to a normality into volume or molarity into N factor into volume. Next weight we must find by equivalent weight of magnesium. Magnesium changes to 2 plus. Therefore N factor is 2. Atomic weight by 2. 24 by 2 into 1000 equal to molarity is given 0.1 into here N factor. So NO3 minus changes to NH3. Here N state plus 5 and here N state minus 3. So change in oxidation state N factor 5 minus of minus 3 which is equal to plus 8 N factor. Therefore 8 into volume 100 mm. So which is 80. So therefore weight by 12 into 1000 equal to 80. That implies weight equal to 12 into 80 by 1000. Therefore weight will be 0 0 cancel, 0.96 grams of magnesium required. Therefore option A. Next. This is a simple question. Oxidation state Br3O8 structure double bond O, here double bond O, double bond and double bond. Here oxidation states -2, -2 and -2. Therefore it should be +6. So here there is no change in oxidation state with this bond. Here also there is no change. Here -2, -2. Therefore for this bromine +4. Here also -2, -2 and -2. Therefore for this +6. So oxidation states +6, +4 and +6 respectively. Option B. This is NCERT question only. Next one. An alloy of metals X and Y weighs 12 grams and contains X and Y in the ratio of 2:5. The percentage of metal X in the alloy is 20% by mass. If the atomic mass of X is 40, what is the atomic mass of Y? Simple question only. First, mass of X in Ly, that is given 20%. 20% must be there. 20%. That means simply, so total weight 12 grams. In 12 grams 20%. 12 into 20 by 100. Therefore it will be 2.4 grams. Next, similarly, mass of Y in Ly. Total 12 grams. In that X is 2.4 grams. Therefore 12 minus 2.4, which is equal to 9.6 grams. So first I have calculated weights. Next, number of X atoms. Number of gram atoms into Avogadro's number. That means number of gram atoms means given weight by atomic weight. Atomic weight 40 is given. 2.4 by 40 into Avogadro's number. 6 into 10 power 23. We'll get this as 3.6 into 10 power 22 atoms. Next, ratio of X and Y. 2:5 is given. 2:5. Therefore, number of Y atoms. Number of Y atoms equal to 3.6 into 10 power 22 into 5 by 2. Get this value as 9 into 10 power 22. Next, 9 into 10 power 22 Y atoms present in 9.6 grams. Therefore, 6 into 10 power 23 Y atoms present in, say, this is X grams. Therefore, X equal to 64. So 6 into 10 power 23 atoms must be present in atomic weight. Therefore, this will be atomic weight of Y. Therefore, answer 64. Standard condition 16. Avogadro's number of atoms will be present in atomic weight. Therefore, X will be atomic weight 64. Next question. So, among the following, which acts as self-indicator? So, self-indicator means MnO4 minus acts as self-indicator due to its color change. Due to its color change. MnO4 minus color will be pink color. It changes to colorless in redox titrations. Therefore, it acts as self-indicator. Indicator means which gives information about end point of titration. So at end point, color will be changed. Color of indicator will be changed. Here MnO4 acts as self-indicator due to its color change. Simple question. Next. So which are the following represents disproportionation of potassium chlorate? Potassium chlorate. Check here. Disproportionation means single oxidation state will be divided into, I am taking here KClO4 plus KCl. So here Cl oxidation state, here plus 5, here plus 7 and here minus 1. So same substance undergoes, see here, plus 5 to plus 7 oxidation and plus 5 to minus 1 is reduction. That means same substance undergoes both oxidation and reduction. This is oxidation. Next again, this one reduction. KClO3 undergoes both oxidation and reduction, therefore disproportionation. Option C. You can check remaining options also. Potassium chlorate, first one. Next, second, potassium perchlorate. KCl is potassium chloride. Remember names also. Next. Oxidation number of an element in a compound is evaluated on the basis of certain rules. Which rule is not correct? They are asking. Not correct. So, oxidation state of hydrogen is always plus 1 is given. For hydrogen, two oxidation states, plus 1 and minus 1. When it combines with non-metals. And when it combines with metals. Therefore, statement 1 wrong. Next, the algebraic sum of all the oxidation states of elements in a compound will be equal to 0. That is condition. Next, an element in a free or uncombined state bears oxidation number 0. Free or elementary state, oxidation state of any element in its elementary state or molecular form can be taken as 0. Very, very important. Next, in all its compounds, oxidation state of fluorine is -1. So, fluorine can exhibit only one oxidation state in its compound. Always. Because highest electronegative element. So, due to highest electronegativity, it can exhibit only one oxidation state, which is -1. So, that is also correct. So, first one is incorrect. This one incorrect. That means option A. Next. So, mixture of three gases A, B, C has a pressure of 10 atmospheres and the total number of moles are 10. From this we can calculate weight of C. Here what is given? Three gases Pa plus Pb plus Pc. Total pressure equal to 10 atmospheres. Next, total number of moles Na plus Nb plus Nc equal to 10 moles. These two are given. Next, partial pressure of A and B are 3 and 1. So, Pa equal to 3 atmospheres and Pb equal to 1 atmosphere. Therefore, from this Pc equal to 10 minus 4, which is 6 moles. That means 6 atmospheres pressure. Next, so Pc is partial pressure of C. So partial pressure means from this we can calculate partial pressure of C equal to mole fraction of C into P total. So from this partial pressure of C, 6 equal to mole fraction of C. That means number of moles of C by total number of moles 10 into P total. Therefore, number of moles of C is 6. So number of moles means we can take it as weight of C by molecular weight of C equal to 6. So from this weight of C equal to 6 into molecular weight. Molecular weight is given in problem 2. Therefore, weight of C is 12 grams. Therefore, option A. Very, very important. Next. This is also simple question. Reaction between Fe2 plus and K2Cr2O7. So from this we can write milli equivalents of Fe2 plus equal to redox titration K2Cr2O7. So milli equivalents means we can write normality into volume N1 V1 and here N2 V2. And here molarity is given. So molarity into N factor into V1. Here also molarity into N factor into V2. So for Fe2 plus N factor will be 1. Fe2 plus changes to Fe3 plus. Therefore N factor 1. Next, for potassium dichromate, always N factor equal to 6. Because in acidic medium, it changes to Cr3+. Next, here we should find molarity of KMnO4 we should find. So first here 20 ml of Fe2 plus given. So from this I am calculating here. So I am calculating here normality. Normality into volume is given 20, that is equal to here 0.01 into N factor 6 into volume 20 ml is given. Therefore normality is 0.06. This is for Fe2 plus. Same Fe2 plus is used for milliequivalents of Fe2 plus, milliequivalents of KMnO4. So here normality into volume, again normality into volume, here also normality into volume or molarity into N factor into volume. So normality of Fe2 plus 0.06 into volume 20 ml is given, and molarity here we should find. Molarity into N factor of KMnO4 in acidic medium is 5 into volume is given 20 ml. So therefore molarity equal to 20 cancel 0.06 by 5. So which is 0.012 molar. This is the answer. Option D. So in first case I am calculating, that means I have calculated Fe2 plus normality. Normality of Fe2 plus. So by using normality of Fe2 plus, I have calculated molarity of KMnO4. Two questions are there. Next. So volume of acidified permanganate solution required for complete reaction of I minus. Here also similar. Milliequivalents of potassium permanganate KMnO4 is equal to milliequivalents of I minus. So here N factor in acidic medium 5. Here N factor 1. Here also same. Molarity into N factor into volume equal to, here also same, molarity into N factor into volume, M1 V1 M2 V2. So here volume we should find. Molarity is given 0.02 into N factor 5 into V1, that is equal to, next molarity it is also given 0.01 into N factor 1 into volume 60. So therefore V1 equal to 2 times, that is 6 ml. 6 is the answer, option D. So I minus changes to I2 for each I minus 1 electron. Therefore N factor 1. In acidic medium KMnO4 N factor is 5. Next equilibrium constant Kc for the following. So 2SO2 plus O2 gives 2SO3. Equilibrium constant Kc is given 100. The number of moles of SO3 in 10 liters flask is twice the number of moles of SO2. Therefore, if SO2 is X, SO3 becomes 2X. Therefore, Kc equal to products by reactants, concentrations of products by concentrations of reactants. Kc equal to 2x by 10 square by x by 10 square into number of moles of O2 by 10. That is equal to Kc is given as 100. So from this, number of moles of O2 will get 40 by 100, that is 0.4. 0.4 moles of O2 present in equilibrium mixture. Next. So 40 ml of X molar KMnO4. So here also same. Milliequivalents of KMnO4 equal to milliequivalents of H2C2O4, which is oxalic acid. Acidic medium N factor 5. Here N factor 2. 2H plus ions. So from this, molarity into N factor into V1 equal to molarity into N factor into V2. So here molarity X into N factor 5 into volume 40, that is equal to here molarity 0.02 into N factor 2 into volume 200. Therefore, X value will be 0.04. Option A. So this is the end of the chapter. In next video, I will explain one more lesson. So all the best and thank you.